Today we will be talking about sampling distribution, sample variance, T distribution, F distribution, these things, and then, but I will start with some review about central limit theorem and then go on with our exercises, okay? So I'm starting to share my screen, and this is already shared. Like you already know that I am recording, right? So let me go back and start my discussions. I have my pen, and I will try to put certain things like that along with the discussions here. Arkadaşlar, do you remember what this thing was about? Like, what were we doing? Let me open the chat alongside of my slide. You remember we had the population, and we were sampling from that population. Then we were collecting data, and then from the data we were obtaining statistic, right? Statistic, right? Such as parameters of mean, variance, and such. And then from these statistics, we try to infer. We try to come up with some conclusions about the parameter of the real population. Okay, this was what we were doing until now. And last week we talked about that. And then previously, I talked about the population mean. The sample mean is the estimate of the population mean, right? X bar is the estimate of the population mean. Estimate means I'm trying to come up with some conclusions about the mean. And we had the central limit theorem related to that. And then today we will be talking about, we will be obtaining sample variances to estimate, to predict the population variance, okay? What does sample variance mean, arkadaşlar? Sample variance, do you know what sample variance is? Sample variance, we find the variance of the random sample, right? We find the sample variance of the sample. It's not the actual population variance, but we are trying to estimate. We are trying to understand from the sample itself the population variance. Okay, so this is what we have. This is what we talked previously, and then I will go on with the next slide. I hope it will not freeze. Let me do this. Okay, everybody can see my slide, I hope, regarding the central limit theorem. Do you remember this explanation of central limit theorem? We had from an unknown distribution of the sampling distribution of the mean, right? Sample mean. We have the sample mean. It has a distribution which is approximately normal, something like this. If you remember, we had this distribution. Let me go back. We had this distribution like that. Sorry, I'm trying to get used to this. We have this distribution, right? What is this distribution? Sampling distribution of the sample mean. This is the sample mean. What was this value, arkadaşlar? What was this? This value was the mu value, right? Mu. The actual mean of the population. What is central limit theorem telling us? The sample mean is equal to the population mean, and the distribution of the sample mean is like Gaussian or normal when we have enough number of samples, which is greater than 30. And I showed you that like even though we don't know or we have different sampling distributions of the normal population, all the sampling distribution of the X bars sample means have this Gaussian shape, okay? Normally, if my data is distributed like that, the PDF of my sample random variable is something like that. The sample means have always a normal, approximately normal distribution, okay? If n is greater than 30. This is what we talked about. And we mentioned that there's a z-stat or z distribution or standard normal distribution. Standard normal distribution, right? Normal distribution. We had the z value. Now its mean was 0 and standard deviation is 1. So we are converting our sample means to this distribution, standardized normal distribution, by checking these, right? This is called sample. What is this called? Standard deviation of the sample mean, right? Standard error of the mean. Standard error of the mean. Okay, I'm closing my video right now because there are some instabilities in my connection. Everybody is with me, right? Arkadaşlar, you are with me? I mentioned this 30 last week. This 30 is critical because as we increase the number of samples that we collect, then it will be, then the distribution will be approximately normal. If you remember this, let me go to the next slide like this. If you remember this distribution, do you remember this graph from last week? We have this distribution, okay? And then if we sample from this population, such as like over 30, yes, Zia, I did it in MATLAB. I changed the sample size and then created different means and I plotted the histogram. The histogram was like showing the mean was equal to, the mean of the means was equal to the distribution, the population mean, and the standard deviation of the means is equal to the actual population variance divided by n, right? Do you remember this? Like this is 64 is our sample mean. And if we have something greater than 30, then our the distribution of the sample mean becomes closer to the Gaussian shape. If it is less than 30, it will have a different shape. We will mention it today. It will be like T distribution, okay? This is like a Gaussian distribution, normal distribution, when we have this kind of an approach, which is like obtaining something greater than 30, okay? Let me show this to you. If n is greater than or equal to 30, my shape will be close to Gaussian. If it is less than 30, today we will call it T distribution, and it is somewhat close to normal, but it is not exactly normal. As n increases, it will be close to normal distribution for T distribution, okay? This is what we will discuss today also. So 30 is kind of a threshold. Below 30, we will deal with our samples differently. After 30, we will deal with our samples differently, okay? This is something that you should keep in mind, okay? So if you, I guess you remember all these, and I'm going further, and this is one example we had last week, but we couldn't cover it. And this is a classical example. This is classical example, such as here I have people's body weights. In the US, it was like in 70s, the body weights of these people between 20 and 29, the mean weight was 170 pounds, okay? And standard deviation was 40 pounds. Now we would like to run such a test that the people of this age now, is it something different than this value, okay? The sample mean, if the mean has changed in the last 50 years, okay? Before, in 1970s, the mu was 170 pounds and standard deviation was 40. And now we are doing it in 2020, okay? What should I do arkadaşlar? What should I do if the mean of this is equal to the mean of this now, okay? The mean was 170. The mean is now, we don't know it, but are they equal or not? This is the question, okay? This is the question, and we will be talking about this as we go further in the next part of the course, okay? Did you understand? What should I do to find out whether they are the same or not right now, arkadaşlar? Any answers? Do you have any answers? Well, how should we start this? How should we start this problem? How should we start this problem? How should we start to solve this problem, arkadaşlar? Any answers? Yes, Ömer, we need to get data, right? We have to have data. We have to collect our current data. So we will have a random sampling from now who are between 20 and 29-year-old men, right? So I will collect random samples from this age, and they should be all men, okay? I will collect data, different numbers, such as this one. I will collect 64 people from this population, and I will find out this mean is 173. I will collect another sample. If I collect another sample, I may have something else. Şimdi, what are we trying to do, arkadaşlar? I am trying to do this. Is this value that I find from my sample, this is my sample of 64 people, okay? And I found this as my sample mean. Is this, can I deduce, can I conclude that this mean x1 bar is like, let's say, the mu, is it equal to the actual mu of mu 0? Okay, this is what I'm trying to do. This was 170. Bakın burası kritik. Even though it is like 173, I should be able to conclude that this is they are, let's say, we can hypothesize that they are equal, okay? There is no significant difference between this value and this value. We should be able to tell this. For example, if I have this, and if I know that this was 50 years ago, this was the case, and 50 years ago sigma was equal to 40, and I keep it as it is right now, but I have 64 samples right now, right? What is my new sigma? What is my new sigma? What is my new sigma, arkadaşlar? It was 40 before. Now, bakın, in this case, we think that we know the sigma, okay? We tell that we know the sigma. So it should be like 40 divided by root 64, which is equal to 5, right? That's why we have this 5 here. 170. I will check whether my sample mean that I take from my sample of 64 people, whether it is coming from this distribution. Anlıyor muyuz burayı? I have this distribution from previous years, 50 years ago. It was 40, the standard deviation was 40. Due to the central limit theorem, I got 64 people as my sample. I divide sigma by root n, which I obtain my new sigma as 5. So this sigma, okay, this sigma here is gonna be 5, okay? So my mean is 170, my sigma is 5. So I will check if this 170 is really significantly different from the weight that was the people's average weight, okay, in 70s. This was in 70s. Now I found here today 173. What is my question? Is the average body weight of now different from the average body weight of 50 years ago? From men between 20 and 29. Burası anlaşıldı mı arkadaşlar? What I'm trying to do is, I'm trying to find out that this finding is supporting my idea of the mu today in 20s, mu of in 70s. I'm trying to answer this question. The average body weight now, is it the same with the average body weight 50 years ago? This is my question. And how am I tackling this problem? I take 64 samples, and I know that it was 170 before and 40 as my sigma 50 years ago. I keep it as it is. I feel like I assume that right now, for now, I assume that it is 40 still, okay? My assumption is 40 is still the standard deviation, but because I'm sampling, I'm performing sampling, my new sample standard deviation will be equal to 40 divided by 8, okay? So mu's are the mu's equal for this new case. This is what I'm doing. That's why I am performing the Z statistic. I'm checking the Z table, okay? That's why I have to check the Z table, okay? Let me go back. Let me go back here and then use my pen. So I'm gonna go to the Z table arkadaşlar. How am I gonna do it? I'm gonna say, oh, now it is 173 and it was 170 before. Now my standard deviation for now is 5. Now it is 3 over 5, which is 0.6, right? 0.6. Bakın, I changed from pounds to standard distribution, okay? This is the standard distribution. It is going from 0 to infinity, and I can find out the probabilities here using the Z table, right? Do you remember using the Z table? We were checking this 0.6 and then finding the probability, right, from the Z table. So this is how we go, and this is how we perform some exercises together on Monday. If we have, bakın, this 173 is what? The X bar that I found now, okay? And my question is, if I find 173, is it, can I say that the means are equal? Significant, they don't have any significant difference between these two means, 170 and 173. In statistics, because there are errors, because there are variations, I cannot say, oh, it should be 170 now, it was 170. If this is not true, if this is 71, I cannot say this is significantly different. No, this is not the case. Bakın burası kritik. Significantly different. We will call this, we will talk about this later, more in detail. We will be asking if this value 173, is it significantly different than 170 right now, 50 years ago? Okay, I got 173. Is it significantly different? How do I find whether it is significantly different? I do this Z equation. Okay, I put my 173 here, 70 here, divide by standard error of the mean, and I found my Z. Now it is this, this is Z. Then I go and find out the probabilities using this 0.6, which is 0.27 something. Okay, if I say the probability of X bar being less than or equal to or less than 70, 73 is what? Is equal to probability of Z greater than 0.6, which is equal to 0.2743. Okay, and from this I might say the probability is high, and later we will tell you that if it is like less than 0.05, which is the alpha value, okay, we will talk about that today and next week. This is the critical value, okay, critical value. And this I will check, I will compare with this. Is this value less than or greater than this? This is greater than, so it is not significantly different. This is what we will tell, okay? Significantly different. Why? Because 0.27 is greater than 0.05. This p-value should be greater than 0.5. If this is the case, not significant, okay? If this is the case, there is a significant difference. That means there is a significant difference, okay? Such as this example. Here, the p-value is what? The p-value is this, right? The p-value is this. What does this p-value tell me? If my X bar is equal to 185, how do I find Z? How do I find Z? 185 minus what? Minus 170 divided by 5, which is equal to 3.0, right? As we mentioned here. What does it mean? 3 is here. The probability is very low. What does it mean, arkadaşlar? What does it mean if I get Z equal to 3? Can I tell that this difference is significant? The difference is significant. Değil mi? What does it say? Now, the body weight of today's young man has changed. It is significantly different from the previous year's body weight, average body weight. Anlıyoruz değil mi burayı arkadaşlar? So if my Z value is small, then I can say the difference is not significant. If Z is high, then I can say the difference is statistically significant. Bakın tabir bu. Statistically significant. statistically significant because I will have different X bars. I may have different X bars. If I go to Kayseri and ask 100 people, I may get different values. If I go to Istanbul, it might be different. If I go to Hakkari, it might be different. So I should check whether this sample is representing, whether this sample is different from 50 years ago, okay? In terms of what? In terms of the mean. In terms of the mean. I talked about that last week, and I tried to pronounce it again so that you remember what we did last time. If you remember again, we have this distribution, and I showed you in MATLAB about this. We have this distribution of the sample mean, and from that, I might get different sample means from each sample, and I can check that whether this 173 value shows a significant difference between the body weights of 50 years ago. Okay, that's the main idea here. Okay, I hope you got the point. Nasıl başlıyoruz? Beyza is asking one thing. Can you explain why we use these statistics but don't use others? Thank you very much. Very, very important question. I was gonna have a poll for that, but I'm gonna explain it right now. Arkadaşlar, if we know, let me go back. If we know mu and sigma of the population, okay, of the population, then if we would like to find out if my sample mean is significantly different from another value, another mean, okay, another mean, or the population mean here. We did such examples. We use Z statistics, okay? This is important, Z statistic, okay? If why taking more sample changes the significance? Because if we look at, as you mentioned, sigma is the sigma, let's say, standard error of the mean is equal to sigma over root n, right? So what do we mean by that? If I increase sample from 64 to, let's say, 256, what happens? The sigma value goes from sigma over 8 to sigma over 16. That means sigma drops 1/2. What does it mean, sigma drops 1/2? Now I can know it better. Değil mi? Sigma is smaller here, but in this one, sigma is larger, okay? So that means I can now know the x bars better, okay? Why taking more sample changes the significance? Because then Z is equal to this divided by standard error of the mean, right? So the standard error of the mean is decreasing. Standard error of the mean decreasing. So Z value will be changing, right? So if this was like, instead of 0.6, it would be, if it is like 1.0, then I would have something like that, even though I have the same mean. This is the same mean, but now the Z corresponding value will be 1, right? Same mean, but different Z values. Why? Because I have different ends, okay? when we plot the means of samples, we obtain a normal distribution. That's why we are using z-score. Yes, that's why, tekrar burayı ifade edeyim. Standard error of, this is what? This is the X bar distribution, right? Distribution of the means. And this is mu, I know it. This is sigma, I know it. If this is the case, I can convert this to z and then find out the z value. From the z value, I can find out the probability. Okay? So this is how we go. If the sample mean of 180 is now, does the population mean indicate that it is illogical for today? No, what we are asking is the body weight of people, or men, now differs from the previous data. And our people are getting more obese, right? In which condition there is I will talk about that in coming weeks, arkadaşlar. The significance value will be more clear to you. Then we will use the z-test, okay? In the next week, we will use the t-test, f-test. All of these are used to find out the significance, statistical significance, okay? This is something that we are doing right now. This using these statistics, we will perform z-test. This is what we are doing actually right now. If we are using t-distribution, we will be using t-test. If we are using f-distribution and two means, two variances, then we will use f-test. And we will be always checking whether there is a significant difference between the current mu and the actual mu, or the mu's of two different populations, or the variances of two different populations. We will be comparing these two using this approach, arkadaşlar. Okay? I hope you got the message. This is like the z-score. If I know mu and sigma, then I use z statistic. Okay? Why? Because now I know all the parameters of the normal distribution. Okay? So this is what I would like to explain right now. I would like to go further with this one and then talk about the sample distribution of the sample variance. Is there any problem in terms of the z-score, arkadaşlar, z-test or z-score or z-distribution? It is critical if we know the mu and sigma. If they are given to me, then I will be able to perform z-score if the number of samples are greater than 30. Let me write again here, or let me go back and write over here. If mu sigma known and n is greater than 30, then I will use z-score. Okay? This is because now I can represent my distribution. I can represent my distribution as a normal Gaussian, standard Gaussian distribution, standard normal distribution, right? This is how I can represent it. What is z-score? Z-score is this value here. And from the z-score, I can find out the probabilities. If they are greater than this, less than this. For example, here z is 3. Then the probability under this curve is very low. That means if I sample Kayseri people with 185 body weight, then it means now people are more obese. People are, or men are more obese right now. Obese böyle mi yazılıyordu bilmiyorum. Obese. Do you know? More weight. They are more heavy. They are more fat. Okay? Because now overweight, yes, thank you. Because they are now, it was before it was 170, now it is 185. Okay. Okay, I'm moving along and then see what is coming. This is the theorem that you read about, sample distribution over sample variance. This is how we talk about this. Okay, so we know that the sample mean is this, right? I collect all the samples and divide by the number of observations, and I will find the sample mean. Okay, this is easy. But we have to be careful that still I have my normal distribution. Okay, the random variables are coming from the normal distribution. Okay, this is critical because in some cases we will not say that this is true. Now I am assuming that the distribution is normal. Okay, the random variables are distributed normally, which with mu and sigma. Okay, mu and sigma square. Şimdi now what I'm doing here is like this is already known, but we will be focusing on this one. Okay, some people are asking, why do we have 1 over n minus 1? We will talk about that in a couple of weeks, which is called unbiased estimator of the variance. So we have to subtract 1 from the number of samples, even though they are n. I have to subtract n minus 1, so that I will find out the sample variance. Okay. Do you understand sample variance, arkadaşlar? Sample variance. Let me show you one thing here from my MATLAB. I'm gonna show you something. Let me share I will share this right now, my MATLAB screen. Okay, can you see my MATLAB screen, arkadaşlar? Yes. Okay. So if you remember this, what did we have last week? We were generating some random samples of, let's say, 10 each, okay? And the mean average of the Poisson, average number of people entering the shop, is 5 for the Poisson distribution. And I'm doing this 10,000 times, okay? And then I'm sampling and then finding out the variance of each sample of 10 data. Burayı anlıyor muyuz, şu farkı, geçen haftadan farkı? It was mean here, if you remember. It was mean. If I run this, I was obtaining the central limit theorem explanation, right? We have 10 samples. We have the Poisson distribution. The means are approximately normal. If I increase the number of samples, then I will find out the mean distribution is close to normal, even more, okay? Now, what I'm trying to do right now, I'm gonna sample, again, 10 samples from a random Poisson distribution, give them as the sample, and then I'm gonna find out the variance of those samples, okay? The variance of these 10 samples from Poisson distribution with 5 mean, okay? Then I'm gonna plot the histogram of that, okay? Are you ready for that, arkadaşlar? Are you ready? Yes? Let's see how it goes. This is a distribution. What kind of a distribution is this, arkadaşlar? Do you remember this distribution graphics? What does it represent? What kind of a distribution is this? You don't see the graph? Let me, pardon arkadaşlar, let me share the whole desktop right now. Can you see the figure right now, arkadaşlar? Yes. What kind of a figure, what kind of distribution do you see here? What type of distribution? Does it look like a normal distribution? Chi-squared, very nice, thank you. Beyza, Furkan, Bilal, very nice. Chi-squared distribution, okay? Sometimes they call it chi-square, sometimes chi-squared. Don't get confused, they are the same thing, chi-square or chi-squared, okay? What is chi? Let me show you here. I will show you there later, sorry. This is chi-squared, right? Chi-square distribution. What is this representing us? Sample variances. This is the sample variance, okay? Chi-square distribution's mean is 5, somewhere here, okay? If I do it 20, now it is still chi-squared, but it is a little bit more close to normal distribution, right? Now I'm increasing it to 40. It is even more closer to normal distribution, okay? So what am I trying to tell you is that this var samp is like this value, this variance, okay? Variance is here, okay? I am collecting samples of n variables, and then I do it several times. Bakın, I do it several times, and then my variance distribution of the sample variance is something like a chi-squared random variable. Bakın, this is critical. This is the random variable right now, not only this variance times n-1 divided by sigma squared must be a chi-squared random variable with n-1 degrees of freedom. If I have 40 samples, my degrees of freedom is 39, okay? Degrees of freedom is the number of samples minus 1. Can you see that, arkadaşlar? Number of observations in each random sample minus 1 is my degrees of freedom. Let me move that over here and you will see it better, I guess. Okay, this is my degrees of freedom, n minus 1. Why is it minus 1? Because this is how it is defined, and we will talk about that again later. But you have mentioned that in your exercises, homework assignments, you have found the definition of degrees of freedom. It is actually the number of observations in each random sample minus 1, okay? Don't get confused with other definitions. One fixed, others free. Yeah, that's what Bilal said, and that's true. We know one thing, and then the others are unknown, because we now know that we know the sample mean, and then from the sample mean we do all the calculations. That's why the degrees of freedom is the number of observations minus 1, but it has some other explanations. But don't get confused yourselves. Please think about this, and if you see degrees of freedom, it is always n minus 1, okay? Did you understand this part? Our sample variance, we find our sample variance from our data, and n minus 1 times the sample variance divided by the population sample variance, population variance is chi-squared, has a chi-squared distribution, okay? So here you can see this chi-squared distribution a little bit better right now. This is chi, bakın bu chi, this is a special symbol we use. Chi-squared is the distribution type, which we mentioned previously, chi-squared distribution. And alpha is my critical value, which we will talk more on that as we go further, okay? Alpha is my critical value, and this is the chi-square distribution. What do we say here in terms of sample distribution? Sample distribution of the sample variance. Sample distribution of the sample variance is S squared, but from the formulations, we find it like, if you remember arkadaşlar, let me go back to here. Let me open my full screen. Let me put it over here. Bakın, for example, if I divide this S square by, if I take this here, it will be n minus 1 times S square, right? Then this will go away, and I will have n minus 1 S square is equal to this, right? Then I will divide both sides by sigma squared, okay? Sigma squared. Then this is something like this, right? Xi minus X bar divided by sigma squared, right? What is this? Xi, or the sample mean, any sample mean from a random sample. This is the sample mean of the sample means. Mean of the sample means, okay? Sample means, which what is it? X bar. What is this one? Mean of one sample. Mean of one sample. One sample means n data, okay? And one sampling, let's say, one sampling, n data, okay? N observations. Burası anlaşıldı mı arkadaşlar? So what I'm doing here is I'm trying to show you the relationship between this. What did I say about this? This is chi-squared distribution. This has chi-squared distribution. Okay? This has chi-squared distribution. And there are different explanations of that. I don't want you to get more into detail about those derivations. I just want you to know this is the situation, okay? N minus 1 S squared divided by sigma squared must be a chi-squared random variable with n minus 1 degrees of freedom. Why is this necessary? Let me show you one example of chi-square distribution table. Bakın here, it's a little bit different table. This new is what? This new is what arkadaşlar? Degrees of freedom, right? New is degrees of freedom, which is n minus 1. What is this value? 995, my critical value. So I will compare with this critical value, okay? If I go, you see, this is, for example, the n minus 1 is 5. And if I'm after alpha is equal to 95, ne demek bu 95? So this is the area under this part is 0.95. Somewhere here, right? Somewhere here, 95. If alpha is, the value is, the chi-squared value is, let's say, this one, 115, 1145, okay? Then this value is 1145. Then the area under the curve is gonna be 0.95 when I know n minus 1 is 5. If I increase the degrees of freedom, the value will increase, right? The value will go from this point to that point. Now it will be something like that. Burayı anlayabildik mi acaba? Tekrar bir göstermek istiyorum. What is alpha? Arkadaşlar, alpha is something that we will decide, okay? In the next part of the course, we will be talking about alpha. Alpha is again significance level, okay? Significance level, or critical value, we call it, okay? In research articles, you're gonna see our alpha is equal to 0.05. This is our critical value. And if the p-value is less than 0.05, then we will say that this is significantly different, okay? But this is what is coming, okay? Don't get confused. Alpha is this, the area under the curve, okay? Here, but this chi-squared value, will change as alpha changes, and what changes? Degrees of freedom changes. Burası ilginç. Yani normally if it is like a normal distribution, we don't have a degrees of freedom situation, because we feel that if n is greater than 30, it has this distribution shape. But for chi-square distribution, it has this distribution type, and it depends on the degrees of freedom. Okay, it depends on the degrees of freedom, as we said here. This is degrees of freedom. What did we say? Kappa chi-squared of n-1. So kappa squared is a chi-square distribution. Why, hocam, why 95%? It is a kind of, what do we say in this case? We will use, in the next parts of the course, we will use 99%, 95%, or 90. These are some very high, commonly used alpha values, okay? 95 is something in between. What do we say? I am 95% confident that this mean is equal to the population mean. This is how we will tell. If you remember, what did we say? If z is 0.20, 0.6, what did we say? The probability is 0.24 something, and the probability is greater than 95, or if the area under the curve here, then it is not, there is a significant difference if there is something here. But if it is close to that point, then it is, we can tell that this is not significantly different, okay? This is a kind of threshold point, which we, just like in central limit theorem, like it was 30, then we will, here we will use these values as our critical values. You see 99%, 95%, 90%. These are the most commonly used critical values, okay? So as we go further, you will understand these better, I hope, okay? Let me solve one question here. Do you remember this question that you solved in your exercises? How did we go further, arkadaşlar? What do we do first? We found the variances, right? Find the variances first. Okay. Then what do? We do chi-squared conversion from s squared to chi-squared. Why is this 4? Why is this 4, arkadaşlar? Because n-1, right? Because 5 minus 1. Because I have 1, 2, 3, 4, 5 data, 5 observations. So n minus 1 is going to be the degrees of freedom. So it is 4. What is this? This is my variance from my sample. This is the variance from my sample. I can use MATLAB, Excel, or anything like that. You don't have to do it with your hands. You can use anything you want, okay? So what is this 1 here? The standard deviation that is given to me. I know standard deviation right now, and I will go from S squared to chi squared, and then I will find 3.26. What is the next step? What is the next step? And here is another example. Here's another explanation. The 95% of a chi-square distribution lies between this value and this value. Do you remember this, arkadaşlar? If you remember that 95, so it is like 95% of the cases are between this and this, right? So this is how we explain things. So let me go back here. So for chi-squared values with 4 degrees of freedom fall between this and this value. Do you know how we find these, arkadaşlar? Let me show you this from the book. Okay, I will go to the statistical table, and I will go to the chi-square distribution. Chi-square distribution. This is normal. This is T. This is chi-square distribution. Okay. What does it tell me? What does the slide tell me? Chi-square degrees of freedom with 4 fall between this and this value. Okay. So how do I do this? 975, and I come here. Bakın nasıl okuyorum bu şeyi? Alpha value is 0.975. Degrees of freedom is 4. So I find this value here, and as mentioned here, okay? And then I will go to this alpha value, 0.0025, in the next page, 0.0025, 4, and this is 11. So what is being asked? 95% of the time, chi-squared values with 4 degrees of freedom fall between these two. Why? Because these are the critical values. These are the things that we should be careful about. What does it tell me? Let me show you here. Let me show you here. Now, what is, pardon. One of them is 0.025. Pardon, şurada olacak. Alfamız 0.025, which is here. It is like 11 point something. And here, 0.4 something, right? And the area here is going to be equal to 0.975. Burayı anlatabildim mi acaba arkadaşlar? So how do we determine these 95%? So this is 0.25 and this is 0. The area here is here. So I will have a small value which is 0.4. I will have a large value which is 11 point something. The area here between these two things is equal to 0.95. Okay, the area between these two critical points is equal to 0.95, and this is being asked in the question. Evet. So what did we find? What did we find here? 3.26. This is my value. Is it between these two? Yes. Then I can say that sigma squared, chi-squared value, I can easily say that the standard deviation is still the same, because we are, we should say that with 95% confidence, I will tell this. With 95% confidence, yani %95 oranında söyleyebilirim ki standart deviyasyon bu örnekte değişmiyor demiş oluyoruz. Okay? 95% confidence, our standard deviation or the variance is not different from what we expected. Burayı anlatabildim mi acaba arkadaşlar? Biraz uzadı da olayımız ama inşallah bir soru daha çözelim birlikte. Can you see what I'm writing here? Yes. Evet. How would you find the probability that a random sample of 25 observations from a normal population with variance will have a sample variance of S square greater than 99.1. So S square is given like 9.1, let's say. What should I do next, arkadaşlar? What should I do next? Go from S square to chi-square, right? What is chi-square? N minus 1 times S square divided by what? Divided by sigma, or sigma squared. Yes, variance. What is S squared? Sample variance. Okay, sample variance that we observe from our 25 observations. What is this one? Population variance. It is given to me, or it is just an expectation that we will have from our specs, from our specifications in our product, okay? From here, and I will say, how many observations? 25 minus 1, 24, times 9.1 divided by what? 6, which is sigma squared. What is the result? 4 times 9.1, which is 36.4. So my chi-squared value is 36.4. Okay, now my chi-squared, when I plot my chi-squared distribution like that, where is this value? Over here, 36.4. Okay, now I'm going to find out the probability. Greater than 9.1, that means greater than 36.4. Okay, now I'm going to go from here to probability. How will I do that? How will I do that? From the table. Let's go back to the table. Okay, let's go back to the table. What should I do? What is the degrees of freedom? 24. I will come here, 24. Degrees of freedom is 24. So I will go, what was my value for this 36.4, right? So this is degrees of freedom. This is 36.41, and I can say that alpha is 0.05. Okay, so what does it mean? What does it mean here? So that means I have my chi-square distribution. I have my data here, 30.5, This is 0.05. The probability of having a chi-squared value greater than 36.4 is equal to 0.05. Okay? So this is, yes, Bilal, 95% confidence. So this is the probability. So how will I do this? How will I solve this part, arkadaşlar? Again, I will go back to the table. I will go back to the table. Again, 24, right? What are the values? 3.4. Again, 24. 3. We'll have a sample variance between this and this. So sigma will be, I should first convert everything, right? Değil mi arkadaşlar? Before going further, I have to do this. 24 times 3.462 divided by 6, which is somewhere close to 13. And then I will do this for this one, 24 times 10.7 divided by 6. This is something like 43, let's say. So I will check from the table chi-squared values. This is the trick, arkadaşlar. We don't directly use s-squared values, okay? We use what? We use these values to go back to the chi-squared values, okay? This is the trick in finding the sample variances, the probabilities of sample variances. Any questions here, arkadaşlar? What did I do? Let me summarize again. From the observations, I calculate what? I calculate what from the observations, arkadaşlar? Let's say n observations. What do I do next? What do I do next? From n observations, what do I do? Benimle misiniz arkadaşlar? Koptunuz mu? Geliyor musunuz? Bakın, I have the observations, okay? I have the observations. What do? I find the variance, sample variance. Bakın, öncelikle I calculate my sample variance, right? Then from sample variance, I use the degrees of freedom times my sample variance divided by either the given or the expected population variance, and find the chi-squared distribution with degrees of freedom n-1. Here we find a value 5, 35, something like that, okay? What do we do with this? Go to the table. Table is has the n-1s here. Table has this 99, 95, or those kind of things. And from 24, we will go and find out this chi-squared values, okay? In order to find the area under the curve, which represents the probabilities also. Bu özet anlaşıldı mı acaba arkadaşlar? So I hope you got the main message here, and then this is another example from the book, and I will end up with this example for today, and we will continue on Monday, inshallah. The scores on a placement test. given to the college freshmen for the past 5 years are approximately normally distributed with a mean this and variance this. Would you still consider this sigma squared as 8 to be valid value of the variance if a random sample of 20 students who take the placement test this year obtain a value of s squared equals 20? Yani, what is it asking? From this s square value, okay? From this s square value, can I calculate the chi-squared value arkadaşlar? 20 minus 1 times 20 divided by 8, which is equal to 47.5. What should I do next? What should I do next? Table, right? I'm gonna go and check the table for chi-squared is equal to 47.5, whose degrees of freedom is equal to 19, right? I will go to the table again. My degrees of freedom is 19. I come here, 19, and check my value again, 47.5. 47.5. So I don't have it here. I should continue. Sorry. 19. 43. What is the alpha value? 0.001. What can I say here? Alpha is even less than 0.0001, right? Değil mi arkadaşlar? From the table, it's like 47. I don't have it in the table. So the last value in the table for the degrees of freedom 19, it was 43. What shall I say? What shall I say arkadaşlar? Now it is even the alpha value, the area under the curve is even less than this value, right? Less than 1 in 1,000. So it is something like this. So the value is somewhere here, 47. Bakın bu chi-square distribution is special for 19. For another one, it is something like that. For another one, it is something like that. So for all different degrees of freedom, I plot different curves and I find different alpha values. Anlıyor muyuz acaba? Less than 1 over 1,000 or 1 point. Değil mi? So what would be the conclusion of this question? Would you still think the variance is 8? No, it is not, right? This sample set, we cannot say that the population variance is still valid for this group of students. Okay, you got the message about sample variance, right? What was the topic again? Sample distribution of the sample variance. So sample distribution of the sample variance. We start from a square from our data, then go to chi-squared. From chi-squared, go to table A5 or anything, any MATLAB you want. From the table, please go to the degrees of freedom row, and from the degrees of freedom row, you find the alpha value and check whether this alpha value is really high or low. If it is high, if it is something like 0.95 or something, then you might say that this is valid. Okay. For example, if the s squared would be 10, what would be the result? 19 times 10 divided by 8, which is something like, let's say 21, right? Now I should check 21 instead of 47 and then find the new alpha. Let us find it. Let us find it for 1921. For 1921. You see, the area under the curve is 0.30. Okay? The area under the curve is 0.30 for s squared is equal to 10. Yes, I know, I'm gonna finish in a minute. So from s squared 10, I found chi squared equal to 21, something like 21. From here, I found the alpha value being equal to 0.30. Okay, so I can say that it's a valid. It would be a valid value of the variance if sigma squared would be 10. But because it is 20, chi squared became 47, and alpha value was equal to a very small value, even less than 1 in 1,000. Okay, I hope you got the message, and we will continue with the T distribution, F distribution, and with some examples on Monday, inshallah. Okay, you understood the basic topic about population variance, and hope to see you on Monday, arkadaşlar. Thank you for joining and engaging with the course. Hopefully, let me do one poll and then go further, and then I will let you go, arkadaşlar. Let me start a poll. Was this effective? Please give me a number out of 5. Okay, let me save this. I'm launching it. Did you find this explanation effective, arkadaşlar? Don't go. Please give some response, and then like on Monday we will continue, and hopefully will be more effective as we go. Everybody can see it. I know now 16 people have voted. Ömer? Okay. I'm ending the poll. I'm sharing the results. Most people find it effective. Hopefully, it wasn't easy to explain things. Sorry for such inconveniences, and hope to see you on Monday, inshallah. On Monday at 11:10, okay? I will start the course as it is starting. It will start at 11:10. See you in 3 days then.